Bloom filter. Which problem is Bloom filter solving? While looking at the technology, it's easy to skip the part of which problem is this technology solving and go directly to the implementation of this technology. And while we do this, we skip the actual essence of the technology. So basically, Bloom filters is here to answer a simple question: is this thing exists or not? But hey, you say we already know how to answer a question: does this thing exist or not? Let's say that someone calls our service, request an image. We can just go to the image server and check if this image exists or not. So what do we need the Bloom filter for? To answer the same question that our servers already know to answer whether a thing exists or not. So it's an optimization. Bloom filter exists inside memory. It utilizes the concept of memory addresses and arrays when we can get directly an answer by going to memory, going to this address, checking whether a bit is set or not. A bit is also an optimization. So instead of going to a service or to a whole database, what we do is go to a memory address, check if something exists, and return immediately the answer. Because this memory structure is small, and we'll see why it's small, then this means that all the front-end servers, the servers that are directly communicating with the backends, can already have this memory structure and return the result immediately without going actually to the other backend services. How we implement the Bloom filter is, yet again, we'll use hashing. What we usually do with hashing is that we convert one data structure into an array, because whenever we want something fast response to return something very fast, then array is our best friend, because with array we go directly to an address and return directly the result. But the way to convert, let's say, an image name into an address is to hash it, because if we want to get something from an array, we need to go to the address. To get to the address, we need a number. To get a number from an image name, we would need to convert it to a number consistently. And to convert something consistently to a number, we're going to perform hashing on it. So someone is posting, calling us and creating a new image. And before we store it to the database, we can just go and have a Bloom filter of size, let's say 300 bits, hash this image name. Let's say the image name was pretty.jpg. So we hash pretty.jpg. We get bit number 31. We set bit 31 to 1. This does not say that if we hashed again ugly.jpg, it would not get also this same bit. So Bloom filter, if it tells us that something exists, we can continue. We can continue going to the other servers and actually ask for this image. But if we'll check the bit and it's 0, this means that no image, not pretty JPEG, not ugly JPEG, not pretty PNG, not ugly PNG, no image is hashed into this item on the cell. So basically we have here the size of the array, the size of the number of bits. We're using bits so that it can be very compact, stored in memory. And then based on the first answer, which is pretty immediate because we just go to a memory address in the array and get the value, based on this result, we can decide whether we want to continue the process of actually fetching the image, because if we didn't ask the Bloom filter, the array, whether this image exists and it does not exist, we would incur all the overhead of going to the image server and trying to return the image. And if it didn't exist already, we could tell this by hashing the image name, then doing a mod on the image name such that it would convert it to the 300 bits. Let's say the mod of the hash would give us 31. We would go to bit number 31 on the Bloom filter and check if this image exists. If it's 1, then it may or may not. If it's 0, it's for sure does not exist, and we can return that the image does not exist immediately. So Bloom filters, this was the simple case. In the more complex case, they can control the size of the Bloom filter and they can set a few bits so that there would be no collisions.